All right, here we go with another IB question. Now, I don't know if you knew this, but down in Chile, when they say the word question, they actually don't mean question. And you may say, but Metabauer in Chile don't speak English, they speak Spanish. And I said, well, yeah, that is very true. And that's why question doesn't mean question, because question is pregunta. But question in Chile actually means thing, which kind of works either way. This is an IB question. This is IB, another one of those IB things. Yeah, it works that way too. Anyway, that has nothing to do with this, but I don't really care. Anyway, so we are going to answer this question. We got the graphs of y equals 3 over 2x minus 3, absolute value or modulus, whatever you want to call it. So there you go, right there. That's this one. All right, then we got y equals 3. That's your horizontal line here. And then you've got a quadratic, all intersecting at the same 2 points. Ain't that fancy? All right, so then given the minimum value of the quadratic function is negative 3, which is very kindly shown right here for us, find an expression for the area of the shaded region in the form 0 to t ax squared plus bx plus c dx. Now, the tough part of this is going to be getting it into that exact format. All right, the easy part is going to be finding a quadratic. Quadratic equations, they are cake, man. So here we go. We're going to find the quadratic first. Now, in order to do that, it would be really nice if I had the vertex, right? So we're going to find the vertex. And to get the vertex, we're going to first find the vertex of our absolute value. So to do that, we're going to find out when y equals 0. So we're going to go 0 equals 3 over 2x minus 3. We add the 3, which is 3. And then we got 3 over 2x. And we multiply both sides by 2/3. And most of you can probably do it faster than this, but I'm just doing this way because I can. And I got 2 equals x. So we now have an x value. All right, now the nice thing about that is I now have the vertex, which is 2, negative 3. Ain't that quaint? And so I can write a quadratic in vertex form. Y equals a, because I don't know the stretch factor yet, but then I can go x minus h squared plus k, which is negative 3. So instead of plus, why don't we just go minus 3? All right, so I got an equation except for the a. So really all I need now is I need to figure out what a is. And in order to do that, I'm just going to take one of these points, and ain't that convenient? They did give us another point right there. Why it's changing colors, I have no idea. But that is just simply 0, 3. So we'll put 0, 3 in here. So we go 3 equals a times 0 minus 2 squared minus 3. And so we can add the 3 and do that squared stuff at the same time. So I got 6 equals a times 0 minus 2. Negative 2 squared is 4, and we divide. So we know that a equals 6 over 4, which is 3 over 2. So there we got a. So at this point, we can actually go ahead and put that in, and we're going to go whoop, whoop. So I got a little bit more space. So I'm going to put everything back in. So my quadratic equation now is going to be y equals 3 over 2 times x minus 2 squared minus 3. So then I go y equals 3 over 2 times x squared minus 4x plus 4 minus 3. And we're going to work that out. So we go y equals 3 halves x squared. 3 halves times 4 would be 12 over 2, which is 6. So minus 6x plus 6 minus 3. And we get our quadratic, which is 3 halves x squared minus 6x plus 3. All right. Now that's all fine and good, but I'm trying to find the area of this shaded region. Now you'll notice there's a absolute value. Absolute values are problems because we cannot do the integral of an absolute value just straight up by hand. What you have to do is you actually have to do the area of the first section, so you can do it this and treat it with a negative slope, and then you do the second part, which then has the positive slope. But you'll notice that this is perfectly symmetrical. It's a parabola, which is symmetrical. It's an absolute value graph, which is symmetrical, and we're looking from one intersection to the other, which means really all we need is the first half and then double it to get the area, the total area. So what we're going to do is we're going to do the integral from 0 up to 2 of, and then here it's the absolute value that's on top. All right, so that line right there would have the equation of negative 3 over 2 x plus 3 All right, that's my linear graph. And then minus your quadratic, which is 3 over 2 x squared minus 6x plus 3 dx. And we're just going to simply find the final equation. Now remember that this will only give me that first section, and so what I need to do is just kind of put a 2 in front to double it to give me both sides. And so from there I know that t is 2, and I just need to kind of finish it off. So I'm going to go 2 integral from 0 to 2, and I've got negative 3 halves x squared. And then this is going to give me a plus 6x, and I got minus 3 over 2, so that'll be plus 12 over 2x, so that'll be 9, so plus 9 over 2x. And then I've got a plus 3 and a minus 3, which are going to cancel out, and I just distribute the 2, and I got the integral from 0 to 2 of negative 3x squared plus 9x dx, and that's actually in the format that they want. And so IB will actually take this if you want it. You can also write out that a equals negative 3, b equals 9, c equals 0, and t equals 2. And there you go. That's pretty much all there is to it.